So in this neural network, we have one input layer, this one, and one output layer, and two hidden layers. So we have input layer 1. We have just one input layer. So I don't really need to write down the number. And then we have two hidden layers. So I say this is first one and this is second one. So we have first hidden layer, and then second hidden layer, and then up layer. And we have 5 nodes here, 4 nodes here, 2 nodes here, and 3 nodes here. So this is how we can describe the architecture of the neural network on the left side. So this is it. And in this slide, I'm gonna explain how neural network is makes calculation. We learned this before. This is called linear regression, and linear regression has these weight values assigned to each descriptor, and this equation can be described in this way. So we have a node, which is an input layer and input nodes, and this is output layer and output node. And you can see that the input node takes input, each input. So if we have more descriptors like a 4 and 5, then input node should be 4 or 5. So number of the descriptors are actually the number of input nodes here. And each descriptor have their weight, so they are multiplied, and then they will be summed up, and these weight connecting input node and output nodes have weight values, and in this model, this weight is used to multiply with this value and this and this with this and this with this, and then they are all together summed here. So this equation actually they are equal to this figure, which is like a neural network. And now we sometimes linear regression fail to predict when the data has much more complicated relationship with input features, descriptors. So it's getting complicated. So this is how, well, basically they are same, but we want to fit the model we want to make the model to catch the more complicated relationship between the input and the output. So we use neural network. So QSAR model takes structure as an input and make a prediction for the target endpoint. And this structure is actually converted into the descriptors. So now in the previous slide we have input layer and output layer, but here we have an input layer, output layer, and hidden layer. And the calculation actually works in the same way. So when the h1 value calculated, they actually do the same thing like a linear regression, because it's connected with this, and this. So use these descriptors and use this weight value to calculate this linear regression. Actually, B is in here, but there is one more thing that's going on, and then this is a part different from the linear regression, and that's called activation function. So it's not just using this linear regression like equation, but also it applies these equation into this function called sigma function. Well, there are actually many different activation function like hyperbolic tangent and ReLU, and so forth. And before deep learning comes in, sigmoid was one of the most popular one used in the neural network. So it's used linear regression, and activation function can be linear, which means doesn't apply any activation function. Or if sigmoid is used, then it's converting these values from 0 to 1. So it's how, so they actually gather the information in these hidden nodes. So that's the calculation. And so H2 can be calculated the same way, like this equation. And then these H1 and H2 is used to make the final prediction. So they are working in this way. So you see, in the hidden layer, activation function was used, but at the output node, activation function wasn't used. So it depends according to the task. And so this is how neural network works. And actually, input was the descriptor, and these values were processed up to output node to make a prediction. So we call it, it's feed forward. So network was fed with the input vector descriptor values, and then these values were calculated with a weight assigned in the each edge, and these and then this value was calculated and transmitted to the next layer and the next layer. So we call it feed forward. This is how your network makes prediction.